Well, I hope you start to realize as we go a little bit deeper into this is a lot of these laws are going to be expansions of what you've already learned. So I'm going to show you a quick video on fractions. Let's say we had a over b to the power of 3. That really means a over b times a over b times a over b, which is a cubed over b cubed. And that's exactly my point. These are both to the power of 1, so therefore it just becomes a cubed b cubed. If you had 3 to the 4th over 2 cubed, it was all squared, you'd really have 3 to the 4th times 3 to the 4th over 2 cubed times 2 cubed, which is 3 to the 8th. 4 times 2 is 8, and 3 times 2 is 6, 2 to the 6th. And that's all. That's all that really is. However, you could have something like this. You could have a over b to the negative 2. Well, that would give you a to the negative 2 and b to the negative 2, but like I said, we now know that that's really the same as the a comes down to the denominator, and the b goes up to the numerator. And that's it. So, actually, I'm going to erase that equal sign. So, if you have something like that, all you have to do, swap those, make that positive. I'm going to rewrite it. You could swap the numerator and the denominator, find the reciprocals, and then make that positive. And then you're left with b squared over a squared. Now that's all. Now I'm going to show you, I will show you this. This is actually super important, and it's actually a brand new law. If you have a base to a fractional power, it's actually equal to the c root of a to the b. So let's take a look at 4 to the power of 3. All right. Well, if you wanted, you could also look at this as 4 to the power of 6 over 2, which would become, and my argument is, the square root of 4 to the power of 6. Well, what is the square root of 4? The square root of 4 is 2. And what's 2 to the 6? It's equal to 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Well, what is 4 cubed? 4 cubed is really 4 times 4 times 4. Oh my goodness. It should give you shivers up your spine. So yeah, take a look. 6. This is a wonky example that I made to work, but they all work that way. It's really my point. I'll give you one more. I'll say let's take 3 to the 3rd. Well, I'm gonna say, well, that's really the same as 3 to the 9 over 3, which would mean the cubed root of 3 to the 9th. Well, 3 to the 9th is going to be some outrageous number. 3 times 3 times 3 times, that's 4, 5, 6, 7, 8, 9. And if you remember from your pre-algebra class, the cubed root means that we can break these into 3 equal groups. So I have 9 numbers. The cubed root would be the value of whatever one of these groups equals. 3 times 3 times 3 is 9, times 3 is 27. 3 cubed is, in fact, 27. And so, if you don't recall that, it is true. And if you don't recall that, then you're going to have to take my word for it. My apologies there. real quick, the square root of 4 is equal to 2 times 2. Nope, is equal to 2, but that's because I need one equal group. Ignore that last statement. In any event, so my big point here is this. The base stays the same. The numerator is your power. And your denominator is your root. Your root is always under your power. I always say, like, if you're searching for a higher power, it's above. If you're looking for roots, they're below. All right? So super, super, super important rule. Please learn that. Thanks. Hope you enjoyed it.